All right, welcome back. Today, we're diving into something that sounds almost like magic, turning the endless sea into fresh, clean drinking water. We're going to look at one of the world's driest regions to see how they pull it off. But you'll see it's a story that's as much about tough compromises as it is about incredible innovation. Okay, let's get into it. I mean, think about it. How on earth do you build a thriving, massive city right in the middle of a desert? You've got these incredible skyscrapers, booming economies, millions of people, all in a place where nature basically forgot to add water. It just doesn't seem possible, does it? Well, that's the big question we're unpacking today. So before we even get to the amazing solutions, we really have to understand just how huge the problem is. We're talking about an environment that is, for all intents and purposes, fundamentally hostile to supporting millions of people. And look, that is not an exaggeration in the slightest. You're dealing with scorching temperatures all year round and these just brutal evaporation rates. So any little bit of water that might show up on the surface, poof, it's gone in a flash. Okay, check this out. Less than 100 millimeters of rain per year. I mean, just to give you some perspective, a city like London gets something like 6 times that much. So what do you do when your natural supply of fresh water is basically zero? You have to get creative. You have to get radical. You literally have to invent your own. And that, right there, brings us to the incredible technology at the heart of this whole story: desalination. I mean, what an audacious idea, right? To take the one thing the region has plenty of, endless seawater, and figure out how to make it drinkable. So how in the world does this even work? Well, the most popular method these days is something called reverse osmosis. Now, that sounds super technical, I know, but the basic idea is actually pretty simple. You're essentially just pushing salt water through a ridiculously fine filter at super high pressure. Let's just quickly walk through the steps. First, you suck in huge volumes of seawater. Then, these massive, powerful pumps create immense pressure, basically slamming that water up against a special membrane. And you can think of this membrane as like a microscopic strainer. It's so fine that the tiny water molecules can squeeze through, but all the bigger stuff, like salt molecules and other gunk, gets blocked. So what do you get on the other side? Pure, fresh water. Okay, so doing this in a lab is one thing, right? Cool science experiment. But taking that science and scaling it up, scaling it up enough to support entire nations, that is a total game changer. That's what changed everything. So let's take a look at what this actually looks like in the real world. Just try to wrap your head around this number for a second. 1 million cubic meters. That's the amount of fresh water the Ras Al Khair plant in Saudi Arabia pumps out every single day. It is an absolutely staggering amount of water, enough to supply a huge capital city like Riyadh. And all of it just created from the sea. And this is where you see the real national impact. Take Israel, for example. Over 70%, think about that, 70% of all their drinking water now comes from desalination. It's completely re-engineered their entire water security. We're not talking about a backup plan. This is the main event. And if you think that's dramatic, check out the United Arab Emirates. It's even more extreme. A mind-blowing 90% of their domestic water supply is from desalination. Cities like Dubai, with all that explosive growth, they are quite literally built on and sustained by water created in these massive plants. So, when you boil it all down, what this technology offers is something incredibly precious: certainty. You're no longer at the mercy of unpredictable rainfall or a changing climate. It's a reliable, basically unlimited source of water. And that reliability, that's what lets you plan for the future, to support huge population growth and build massive economies. Plus, it takes the pressure off the natural underground water sources, which is great. So on the face of it, man, it really does seem like the perfect solution, doesn't it? But of course, you knew there was a but coming, didn't you? This incredible, almost magical power to make fresh water, well, it doesn't come for free. It comes with a pretty hefty price tag, both for the environment and the economy. Yeah, so what is the catch? If this tech is such a perfect fix for one of humanity's oldest and biggest problems, why isn't every country with a coastline doing it? What's the hidden downside to this desert miracle? And this really lays out the central conflict perfectly. On one side, you have this incredible promise, a reliable, basically unlimited source of fresh water. But the price for that promise is steep. It uses a ton of energy and causes real harm to the environment. So let's break down that price. First up, energy. These things are energy hogs. Those high-pressure pumps need a staggering amount of electricity, often from burning fossil fuels. A single big plant can have the same carbon footprint as a small city. Then there's the waste. You get this super salty, chemical-filled gunk called brine. And what do they do with it? They just pump it back into the sea. But it's denser than seawater, so it sinks, smothers the seabed, and creates these toxic dead zones that kill marine ecosystems. And finally, yeah, it's just wildly expensive. We're talking billions of dollars to build and operate these plants. That puts it out of reach for many of the developing countries that need it most. And this leads to a really fascinating, kind of weird paradox. You'd think that creating an infinite supply of water would solve the problem, right? But what if it actually makes it worse in some ways? The evidence suggests that when water feels abundant and cheap, people, well, they just use more of it. It can actually increase demand, locking cities into the cycle of having to build even more and more plants just to keep pace. Which brings us to the big dilemma here. Is desalination a genuine long-term solution for water security, or is it more of a high-tech crutch, something that lets us avoid the harder conversation about how much water we use and how we can be more sustainable? Because at the end of the day, that's really what desalination is. It's a classic techno fix. It's this brilliant, ingenious solution to one problem, not enough water, that just happens to create a whole bunch of new problems, like CO2 emissions and ocean pollution. And so that's the thought I want to leave you with. This whole story really forces us to ask a much bigger question, not just about water, but about our future. Is true security really about inventing our way out of every problem? About believing technology can always create more of whatever we need? Or is it about learning to live more wisely with the finite resources we already have? It's a huge question, and there are definitely no easy answers.